Good morning, everybody. The topic name is probabilistic model based on information retrieval techniques in modeling and retrieval evaluation. This is the most important for every model to evaluate your query. So the query is most important. Whatever query is received from the system, once verified and tokenized, and after alphabetic order, you can identify your position and how many times are identified after positions are once rearranged and give an answer about the last topic. So this is accurate or expected process in the sectors. So problem how to determine important words in a document, word census, word n-grams, and phrase item. The term based on your conditions. How to determine the degree of importance of term within a document and within your entire collections. And how to determine the degree of similarity between documents and query. And in the case of web, what is a collection and what are the effects of links and formatted in the formation. This is a problem statement about the conditions. Shall we move to next one? So this is probability in IR, process thinking based on user information needs and documents, and understanding of user need uncertainty. Uncertainty guess of whether documents are relevant content. In vector space model, matching between each document and queries attempt in semantically and imprecise space of indexed term. And probabilistic provide a principled foundation of uncertainty reasoning based on some quantity or quality base in the sectors. So probability in IA based on classical probability retrieval model, the probability ranking principles binary independence model is called as an Naïve Bayes text CAT. Bayes network for text retrieval language model approach to IR, and this is an important emphasis in recent work in the sectors. The probabilistic method are one of the oldest but one of the currently hottest topic in the IR. So document ranking problem based on we have collection of documents. User issue a query. A list document needs to be returned. The ranking method is a core of IR system. In what order to we present the document to user. And the idea, the rank by probability relevance document based on R equal to 1 divided by document of query in the sectors. So this is for even A and B Bayes rule. So this is Bayes conditions based on P of A comma B and P A of intersection of B, P A bar of B and P of P and P of P bar of A, P of A. This is the overall value P of, O of A, P of A divided by P of A bar equal P of A divided by 1 minus of P of A. This is a Bayes rule to apply in probabilistic in the sector. So let X represent in a document in the collection. Let R represent relevance or document with WRT given fixed query, and let R1 R equal to 1 represent relevant and R equal to 0 not relevant. So need to find P R equal to 1 divided by X minus probability that contain X is relevant. So P R equal to 0 of X plus P R equal to 1 by X equal to 1. This is a condition statement. So next one we go for. So how do we compute all probabilities? Do not know extract probability, have to use estimator. Binary independent model. This is the simplest model and questionable assumption. Relevance based on that one, and duplicated. You keep on returning our duplicates, and term independence of frequency, and term contribution to relevance of treated by independent of events. This is possibility of retrieval strategy. Estimate how the term contribute to relevant. How to think like TF and documents length influence, and your judgment about document relevance once in the sector, and a more answer of Okapi formula, Spark Jones and Robert Sands combined to find document relevance probability, ordered document by degrees probability. So this is a process of binary independent model. Traditional use conjunction with PRP, and binary equal to Boolean document represent binary incidence of vector in CF1. So it is represent x equal to 1, n number of x of n, xi equal to 1 is if term is ith is presented in the document of x. The independent term occur in the document independently. Different documents can be model as the same vectors. So this is binary independent model. The query binary term incidence of vectors give query Q for each document D. It need to be compute and replace with computing where X is binary term incidence vector represent of D. And after that we have using Bayes rule application. This is a formula you can use apply in the sector. So after binary independent, constant for can given query needs of estimation and independent assumption in the answer. The binary independence model, this is a if suppose xi is either 0 or 1, you can use this formula. Suppose you can not occurring in the query, you can use this formula in the conditions. So all matching term, if suppose all documents are matching, you can based on your query, you can accept this formula. If not matching, you can use these conditions. After all matching term, you can apply all queries are term in the sectors. This is binary independence, retrieval status value of RSP equal log by xi equal to qi equal to 1, pi 1 minus ri, ri 1 minus pi. Is epsilon xi equal to qi equal to 1, log pi 1 minus ri, ri 1 minus pi. This is the process of independent model in the sector. This is a binary based on conditions. Your gathering of informations about computing data. This is documents, relevance, non-relevance, and total. This is a coefficient theory of binary independence model. So estimation key challenges in the your information retrieval sector. This is estimation. PI is a probability occurrence of relevant documents. PI can be estimated varies of process. RSV epsilon of xi equal qi equal to 1 log n capital of n divided by ni. You can substitute this value, you can find out the answer in your sectors. This is activity. This is disadvantages. Need to guess the initial ranking. Binary weight ignores frequency, and independent assumption not clear if the bad. This is advantages. Theoretical adequacy rank by probability. This is my assessment. List out the advantage of probability in IRT. Identify the disadvantage of probability in IRT. This is my textbooks.